All right, today we're pulling back the curtain and going deep inside ACE manufacturing to see how the brains behind massive industrial machines are actually made. This is a world where every single connection, every component, and every test is a critical step towards creating flawless automation. So let's dive right in. So, have you ever looked at a giant factory machine, or maybe a super complex robotic arm, and wondered, what's actually making all the decisions? What's telling it exactly what to do? Well, the answer is the industrial control panel. And believe me, it is so much more than just a metal box full of wires. It's really the sophisticated brain and the central nervous system for all of modern automation. It's the thing that translates all those complex digital commands into real, precise, physical action. But before a single wire ever gets connected, the whole process starts right here, in engineering and design. This is literally the blueprint for precision. Every single decision made at this stage lays the foundation for reliability, long before anyone even picks up a tool. And this design process itself is just incredibly detailed. It all kicks off with these super detailed drawings and schematics that map out every last connection. Then the team has to meticulously pick out every single component, making sure it's perfect for the job. And of course, they have to make sure everything meets these super strict global safety standards. But here's the really smart part. They future-proof the design, building in extra room for expansions or maintenance down the road. Excellence is literally engineered in from step one. Okay, so once that digital blueprint is completely locked in, it's time to bring this thing to life. We're moving from the screen to the factory floor, from the blueprint to the build. This is where we construct the physical core of that industrial brain. And ACE builds a whole range of these things. Everything from PLC panels, that stands for Programmable Logic Controller, which is what actually runs the automation, all the way up to these massive motor control centers. But their philosophy is really clear. Only use globally trusted, top-of-the-line components. We're talking high-end VFDs or variable frequency drives that control motor speeds with insane precision and really intuitive HMIs, the human-machine interfaces that the operators use. This commitment to quality parts is just fundamental to everything they do. Now, let's zoom in a little bit on the assembly itself, because this isn't just about connecting point A to point B. Honestly, it's kind of an art form. You've got structured wiring, perfect cable routing, and high-quality parts that all come together to create this impeccably organized layout. It's truly the difference between chaos and control. This is what professional-grade work looks like. And all that neatness, it is not just for show. Think about it. A clean, super organized panel is just plain safer to operate. Plus, when it's time for maintenance, maybe 5 or 10 years down the line, an engineer can pop it open and immediately identify every part and trace every wire. That thoughtful organization saves a ton of time, it reduces errors, and ultimately it makes the whole system more reliable for the long haul. This, you could call it a fanatical attention to detail. It continues right up to the very end. Every single wire gets capped with a little piece called a ferrule just to ensure a rock-solid connection. They use standardized color codes, so everything is crystal clear. Every single screw is tightened to a precise torque setting. There is absolutely no guesswork allowed here. Then, after one last visual and mechanical check, the build is finally done. Because in this world, every single connection matters. Okay, so the panel is built. It looks perfect. But here's the real question. Will it work flawlessly when it's under pressure? Well, now it's time for the final gauntlet. A whole battery of tests to verify that this thing is 100% ready for the tough industrial world. And when I say they test everything, I mean everything. First, they make sure the physical build perfectly matches the engineering drawings. Then they check every single wire for continuity. Then they power it up and simulate real-world conditions. They verify the programming logic of the PLC and drives, and, critically, they test every single safety feature and interlock. Nothing, and I mean nothing, is left to chance. This entire process leads up to one final major event, the factory acceptance test, or what they call FAT for short. You can really think of it as the final exam, a super rigorous, all-encompassing test that the panel has to pass at the factory before it's ever allowed to be shipped out. Now, here's the part that I think is really cool. This is an open invitation. The client, the actual person who's going to be using this panel, can come right to the factory and watch all these final tests happen in person. That just speaks volumes about their commitment to transparency and partnership. The whole point of this FAT is to ensure, and this is a quote, complete transparency, compliance, and confidence before site installation. What that really means is that the client can walk away knowing for certain that the panel they're getting is exactly what they paid for and that it's 100% ready to go to work. So we've basically seen the entire journey, right? From a digital drawing on a computer screen to a fully tested industrial brain. So let's pull all this together and look at what they call the ACE advantage, why this incredibly meticulous process really, truly matters. So, what is the ACE advantage? Well, it's the fact that they control the entire process in-house, from that first design idea to the final build. It's about sticking to global standards, not just the local ones. It's the deep expertise you get from a team of specialists, plus a track record of performance in the toughest environments, and it's all backed up by reliable delivery and long-term support. This right here is really the core promise. Every single step we just walked through, from the future-proof design all the way down to that torque-controlled screw, it's all working towards this one simple goal: to create a panel that is engineered for peak performance, uncompromising safety, and just rock-solid long-term reliability.